Hello class, in this video I'll be showing you how to find the total number of distinguishable permutations. Let's begin. If n objects in a permutation are not all distinguishable, that is, if there are n sub 1 of type 1, n sub 2 of type 2, and so on for our different types, then the number of distinguishable permutations is the following. So that will be n factorial divided by the following product. Okay, so in the first two examples, I'll be showing you how to find the number of total permutations of objects. And in the last two examples in this video, I will be showing you how to find the total number of distinguishable permutations. Here we go. A child has a set of differently shaped plastic objects. There are 3 pyramids, 4 cubes, and 7 spheres. In how many ways can she arrange the objects in a row if each object is a different color? Okay, so we want to arrange the objects. So since we want to arrange the objects, we are looking at a permutation. And each arrangement of these objects is different. And I want to arrange all 14 of them. So this will be a permutation of 14 objects out of 14. So that is 14 factorial divided by 14 minus 14 factorial, which is equal to 14 factorial divided by 0 factorial. And 0 factorial is defined to be 1. So 14 factorial is 8.718 times 10 to the 10th different arrangements. All right. Part B. How many arrangements are possible if objects of the same shape must be grouped together and each object is a different color? Okay, so there are 2 different scenarios going on. So the first one is that the same shapes must be grouped together, and the second is each object is a different color. All right, so we want to first arrange the shapes. And that is going to be a permutation of 3 out of 3 shapes, because we want to arrange all 3 shapes. Next, we want to arrange the colors. All right, so let's take a look at the triangles first. We can rearrange these triangles, and each arrangement is going to be a different arrangement because there are 3 different colors. So the arrangements of the colors for the triangles are going to be 3, 3. So we're going to arrange 3 objects out of 3. There are 4 different squares, each a different color, and each arrangement of those 4 squares is going to be different. So this is going to be multiplied by a permutation of 4 out of 4. And finally, there are 7 circles. Each circle has a different color, so each arrangement of the circles is different. So this is going to be a permutation of 7 out of 7. All right, so now that we have all of the different arrangements, we need to go back to the original problem. And it says the same shape must be grouped together and each object is a different color. So we need to multiply here. So we need to multiply the number of arrangements of the shapes and the number of arrangements of colors. Okay, so that's going to equal 6 times 6 times 24 times 5,040. So in this scenario, there are 4,354,560 different ways, or different arrangements. Okay, part C. If objects of the same shape have the same color, how many different arrangements are possible? Okay, so if we take a look here and we group these triangles, since they are all the same color, each arrangement is identical. So these three objects here are indistinguishable, meaning you can't tell them apart. Here, those four squares are all blue. That means we cannot tell them apart if we were to rearrange them. So these four objects are indistinguishable. And I can say the same thing about these 7 green circles. So these 7 objects are indistinguishable. You can't tell them apart. So we know that we're going to use the distinguishable permutations formula right here. So there are 14 total objects, and there are 3 indistinguishable triangles, 4 indistinguishable squares, and 7 indistinguishable circles. So there are 120,120 different arrangements. All right, and the last one. Assume all shapes have the same color. How many different arrangements are there? All right, so this problem is actually very similar to the one we've just done. So let's take a look at the triangles. Again, if we arrange them in any order, the order is exactly the same. So these 3 objects are indistinguishable. Looking at these 4 squares, all 4 of those squares are identical. So I can't tell them apart, they're indistinguishable. So there are 4 objects here that are indistinguishable. And finally, all 7 circles are indistinguishable from each other. Which means if I rearrange them, we can't tell the arrangements apart. They're all the same. Each arrangement is identical. So again, we have 7 objects are indistinguishable. So this problem is identical to part C. This is going to be 14 factorial divided by 3 factorial, 4 factorial, and 7 factorial. So again, there are 120,120 different arrangements. And we are done.